complex numbers, okay? So what you have is complex numbers are used to describe the size and position of an animated fictional characters and objects in computer games. One interactive simulation game, the main character needs to change size and position in different ways. By evaluating each of the following transformations to the complex number 1 plus 5i, where I squared equals minus 1, describe what happens to the fictional character in each case. You may assume that every point in the character undergoes the same transformation. Okay, ignore the character for the start, right? Just pretend he's not there. Alright? Now, CZ, Z is the point 1 across 5 up. In complex numbers terminology, that's 1 plus 5i. If I describe this point here, minus 2, 3, that's the point minus 2 plus 3i. We cool with that? Alright. Now, the following things are going to happen. What happens when we add 3 onto that complex number? So we're just going to add the number 3 onto that. What happens when you add 3 onto 1 plus 5i? Huh? It turns into 4 plus 5i. Would you agree with that? Because you're adding on 3. Now what does that actually do to the diagram? What was 1 plus 5i has now turned into, anybody? 4 plus 5i. So what has it done to the character? Moved it to the right. So adding on a number moves it to the right, while taking away a number would move it to the left, provided it is at every point. Does everybody get that? Basically, when you add a number onto a complex number, we added 3 onto this number here, and then it turned into 4 plus 5i. And 4 plus 5i, when you draw it, is 3 spaces to the right of the original. Okay? Could anyone in the class tell me what happens if I was to add 3i onto this? What happens if I added plus 3i onto the complex number? What would happen? It go 3 upwards. So it would turn into 1 plus 8i, which means that you'd be up here. So your character, in a way, jumps upwards as opposed to moving sideways. Okay, that's what's going on here. Now, what happens when we change z to minus z? So we have to multiply the whole thing by minus 1. So we're on this part here. Z2 equals minus z, and minus z is minus brackets. What's 1 plus 5i? What answer do I get? Minus 1 minus 5i. Minus 1 minus 5i. And that's an interesting one, isn't it? What happened to the character? Is he facing this way, or is he upside down? He's upside down, but how would you know he's upside down? So you could maybe do another point. You could actually maybe try. You could actually try his bottom right leg. Do you see the bottom? Oh, sorry, his bottom left. If we're looking at a mirror here, okay? His bottom. I know because it's symmetrical. You can be looking away from us or towards us. Right? Now, see this number here, 2 plus 0i, yeah? If we multiply that by minus 1 in the same way, where will that end up? Where will that end up? Minus 2. So it's quite clear to see that this character would be basically just upside down. Is what's happening to him there. So what can we write down here? We can say that the character is reflected through the origin. That's basically reflecting us through the origin. I'll show you why by getting myself a dotted line here. There to there, through the origin. Right leg to right leg through the origin. And you could almost do it like hand to hand through the origin. Now, basically he's upside down, okay? Everybody write that? So it's what do you call it? Central symmetry in what? In the origin. Okay, origin means 0, 0. Okay, everybody right with that? Now, what is Z3 equals Zi? What happens when we multiply Z by I? It's another thing we got to figure out. So Z3 is multiplying I by the original 1 plus 5I. What happens there? We get I and 5I squared. And what is 5I squared? Minus 5 plus I. Now minus 5 plus I, where's that located? Left and up 1. Now, this is a harder one to explain, alright? So, if I were you guys, I wouldn't really have a clue what's happened at this point. I'd actually have to draw 2 more points and figure out what happens to the overall shape. I wouldn't have a clue. So I'm going to draw one of the central parts of his body. I'll draw his neck and then just the point at where the legs meet. Okay? And if I draw those 2 points as well, I'll figure out exactly what's going on here. So my plan would be to draw, what's that, 1 tree, is it? Would you agree with 1 plus 3I? Yeah. Multiply that by I, and I'll get I plus 3I squared, which is minus 3 plus I. Okay, so that's his, that'll be his neck there, yeah? And then I can assume that's, then I have a rough idea of what happened there. What do you think? I think he's folded, I think he's gone 90 degrees. Does that make sense? Because if you look at his left leg should be joining there, and you can see that the left leg folded 90 degrees. I also know that off by heart, that anytime you multiply by I, you actually cause the complex number to rotate 90 degrees. Okay, but if you aren't sure, just draw in the extra point or two, make it do the same thing, and figure it out from there. Everybody alright with that? Okay. So, what's that? It's minus 5 plus I, and you rotate 90 degrees. Now, that's us done for this part. Showing the arc diagram, the fictional character under each transformation defined in part A. So that's what I did earlier, was just drawing each character out as I went along, so that's alright. Now, some transformations require examination of more than 1 point on the fictional character. By considering said and another point, describe what happens to the character under each of the following transformations. So, when you multiply it by 3, what happens? So, said is 1 plus 5I. What happens when you multiply that by 3? Sorry? 3 plus 5I. And pick a second point. Will we pick his neck again, will we? His neck was, anybody remember? The neck? 1 plus 3I. And where does that go? 1 plus 3I will turn into 3 plus 9I. What has actually happened there? Anybody know? We go back.
Why isn't it 3I?
3 times and 3 multiplied by the complex number I chose. So his neck is, I'm going to rub all this out for a minute, just too much stuff on the board. His neck, I'm choosing 2 points, alright? I decided to choose his neck, which is 1 plus 3I, and the top of his head, which is 1 plus 5I. Yeah?
Why did you multiply 5I then?
Oh, sorry, it's 1 plus 5I. I meant to be multiplying both of them, sorry, my bad. So when I multiply both of them by 3, oh, it should be 15I, and that should be 3 plus 15I and 3 plus 9I, my fault. Okay, now how does that compare to what we did earlier? 3 plus 9I is up there, so that's his neck, isn't it? And his head is going to be 2 blocks above that. Oh, sorry, it's going to be 15I, isn't it? So it's now 6 blocks above, isn't it? So it's all the way up to 15, which is 6 blocks above. So the head has actually got a lot bigger. The head was 2 blocks high, now it's 6 blocks high. That makes sense? So what have we done to the size of the object?
Like 3 times 3.
We've tripled it. So what you're going to say down here is explanation, you tripled the object's size. Does that make sense? 3 times bigger. Okay. What happens when you let it equal to its conjugate? What do you mean by conjugate? Huh? You change the I value. So one of them's going to be 1 minus 5i. The second point we're still taking is using the neck, and that's 1 minus 3i. Happy enough with that? So 1 minus 5i, 1 minus 3i. That's what that little bar means. It means the conjugate. Change the sign that comes in front of the I. So what we're looking at here is it's 1 minus 3i, which is this one here. So green turns into that one there, and red turns into that one there. What do you think happens?
That's minus 1 plus 3. That's what you did there.
Oh.
It's 1 minus 5.
Oh, sorry, 1 minus 5i and 1 minus 3i. My fault. I did reflection in the y-axis while conjugates are clearly reflection in the x-axis. Clearly. Now, so I had to do 1 minus 3i and 1 minus 5i for the conjugate. So 1 minus 5i is there, and 1 minus 3i is there, and we can see that the object has been flipped. So reflection in the x-axis. Yeah? Or another word is axial symmetry in the x-axis. So I call it axial symmetry or reflection in the, now it would be called x-axis, but in complex numbers, real axis. I'm sure you won't get that punished for saying x-axis. I put that in the wrong one. Yeah. There we go. Axial symmetry in the x-axis. Now, last one. 2 plus 2i multiplied by z. 2 plus 2i multiplied by z. Now that's going to be difficult enough. So, the 2 points we chose were, we chose 1 plus 5i, and we also chose 1 minus 1 plus 3i. One of them's the top of the head, and the other one is the neck. We got to multiply that by 2 plus 2i, because it says z multiplied by 2 plus 2i. So it doesn't matter which one comes first. Multiply out 2 plus 2i plus 10i plus 10i squared. 2 minus 10 minus 8 plus 12i. Minus 8 plus 12i, okay? And then the other one. Second point is 1 plus 3i. That's minus 8 plus 12i. Multiply it out as well. 2 plus 2i multiplied by that there. And what we get is 2 plus 6i plus 2i plus 6i squared. That's a minus 6. 2 minus 6 is minus 4. Minus 4 plus 8i. I'm going to draw the two of these roughly, okay, just because I don't think I have enough space on the old diagram. So, would everybody agree initially we had the head and the neck here and here? 1 plus 3i and 1 plus 5i, yeah? I know. It's a small technicality, Sam. The arms are sort of relatively irrelevant. It's just the head and the legs I'm looking for. And that touches there, yeah? Now, what we're going to do next, guys, we're going to draw the new points. Minus 8 plus 12i. Minus 8 being all the way over here. And plus 12i bringing it much higher than it was. Yeah? And then the other one is minus 4 plus 8i. Minus 4 being here. 8i being around there. So it rotated it and increased the size. Would you agree with that? Partial clockwise rotation and increase in size. That's all you have to describe. Anti-clockwise rotation, increase in size. Alright? So, in this part here, guys, you just write down anti-clockwise rotation, increase in size. I personally feel that question is a bit on the difficult side, and if they were to ask that, they're asking for trouble. Okay? Alright guys, this one here. Find the height above ground level from which the golf ball is struck. Can anybody tell me, is this an N-shaped curve or a U-shaped curve? It's an N-shaper, okay? Now,
That was the square.
because it's a minus squared. It was a plus squared, it'd be a U-shaper.
Yeah, I can see.
And you, that's
Look at the ball, I think.
yeah. It's basically a formula for what's x again? X the horizontal distance. So basically, in a nutshell, your height is on the x-axis, and your horizontal distance x is on the y-axis. Now, the great thing about this is this table function is an absolute godsend. Okay, so you get 25 plus 0.4x, and then you're going to have your minus 0.002 x squared, yeah? Now, we're going to go from 0 to
20.
we don't actually know. So why not just take the first 20 meters anyway? Yeah. Now look what happens. Step 1. When you've travelled no meters horizontally, you start off at 25. Well look, that answers our first question. H equals 25 when x equals 0. How would you show workings though? You replace x with 0 and you get 25. Okay. Next thing. At the instant the golf ball is struck, a bird passes in the flight path of the ball. Yeah. Two words here, guys. At the instant the golf ball is struck, a bird passes the flight of the ball. The position of the bird is 45 meters above ground level, a horizontal distance of 75 meters. What point does that refer to? It refers to 75 meters in the x direction and 45 meters in the y direction. Now if I go back to my table function, now I've gone from 0 to 20. What happens if I go from 0 to, let's say, 80, but I'm going to go with steps of 5. I can check out, is 75 on my list? 75 and 43 points. In my opinion, that means that it's going to go underneath the bird and not quite reach the bird. Is that alright? So how would you prove that in the exam? You say, find H when x equals 75, because the horizontal distance is 75. Put that into the calculator. What is it? H equals 25 plus 0.4 times 75 minus 0.002 times 75 squared, and lo and behold, the answer is 43.75. So it passes under the bird. But I'd say they're easy marks at the moment. Just do the table function and read the numbers. Okay, it's not that bad. Now, find the horizontal distance that the golf ball has travelled when it reaches its maximum height above ground level. Now, there's a way of doing this if you've forgotten absolutely everything. Okay? Maximum is when height and distance, it's a maximum point is at the very top. Now if you've forgotten all about differentiation, you've forgotten all about stuff like that, what you do is just have a good look at your graph. And when does it stop rising? 44.2 is still rising. So it's still rising at 80 last time I checked. So I'm gonna go to 77. I'll go to about 90. and I'll go up them once. And I'm having a look. Still rising. 79, it's still rising. 80. 81 still going upwards, is it?
Yeah.
82 still going upwards. 83 still upwards. 84 still upwards. 85 is still upwards. 86, 87, 88, 89. It isn't. Alright, still didn't find it. So go again. 90 to maybe 110. Still going upwards. You've got to stop eventually. There we go. Finally. You know your answer is going to be when it reaches 100 meters to the right, it has a maximum height of 45 meters. So we got to prove that using differentiation. However, if you were to forget about differentiation, that's a good backup plan. Okay? Now, what differentiation is, it's a measure of the slope. The first derivative is the slope of a graph. Okay? Now, the one thing about the maximum and minimum points is that the slope is what at the maximum and minimum?
0.
Slope equals 0. So, your first derivative should equal 0. And you can find what x value this happens at. Okay? And we also have to find its maximum height. So, we already know the answer is 100 brackets 45. What this means is that when the x value is 100, the maximum height is 45. Okay? So, what's the formula again? H equals, what is it again? 25 plus 0.4x minus 0.02002 x squared.
Yeah.
Okay, differentiate once. What happens when you differentiate 25? 0. Differentiate any number without the letter, turns to 0. What happens to 0.4x? Just turns to 0.4. What happens to 0.002x squared? Multiply the power by the number that comes in front of it to get 0.004 and then x. We know that the slope is going to be 0. Solve that. 0.004x equals 0.4. X is equal to 0.4 divided by 0.0004, which is equal to 100. Place 100 back into what equation? Anywhere you see x, you're going to replace it with 100 because that will tell you what the height is. And you'll find out that it's 45 when you put it back in. So, because you already have it, you can just say h equals 25 plus 0.4 times 100 minus 0.002 times 100 squared. And off you go. What is the maximum height that the golf ball reaches above the elevated position from which it is struck? Oh, above ground level. Ah, that makes sense. Please remember that at the very beginning of your test, the very beginning of your question even, I think a better way of saying it, 0 to 100, up in steps of 20. You start off 25 metres above the ground. After you cover 20 metres, you're 32.2 metres above the ground. After 100 metres, you were 45. So you realistically only went up 20 metres, didn't you? So just 45 minus 25 equals 20 metres. Go. This is a good one. This is a sequence and series question. Huh? Yeah, I think it was a good one. Now, the Shard, one of the world's newest skyscrapers, the 72-storey clad pyramid tower in London has been widely acclaimed as an architectural masterpiece. Realistically, crap. Oh, 72 stories is useful. That wasn't crap. So the 72 stories is grand, and then you're just like crap. 310 meters high. The buildings, blah blah blah. Crap.
Nope. No.
Good.
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 Good. Alright? But look at the amount of extra junk in there. Okay? Now, they do that. They're very fond of misdirection, using statistical numbers to give you too much. Okay? Now, here's what happens. Construction costs were 1.95 million for the first floor, and then what was it? 0.15 million for everything after that. Okay? So we're going to add them up. We're going to get 2.1, 2.25, 2.4, and 2.55. Everybody alright with that? Yep. Now, find in terms of n a formula for the construction of the nth story of a building. What type of sequence is this? Can anybody tell me? Garmer, do you know what type of sequence this is? A linear. Why is it a linear? All the differences are the same. D equals 0.05, A equals 1.95. You go to your maths tables, you check up the word sequences and series. You go to the page, it opens up. You see the formula for a linear sequence, which is A plus n minus 1 times D. Now, this will tell me the cost of any floor I want. What's the A value? What you start off with. What's the D value? Or sorry, the D value is 0.15. Then you say Tn equals 1.95. Please remember that the n and the minus 1 are both multiplying by the 0.15. 0.15n minus 0.15. One take away the other is 1.8 plus 0.15n. Now, what exactly is this doing? Think of any letter you want, and it will tell you the cost it takes to make that floor. I think it's the cost of... Yeah, so the second floor on its own costs 2.1 million. The third floor on its own costs 2.25 million. If I want to make all three floors, it's all three of them added together is the total cost of the building. Everybody right with that?
Yeah.
Got that much? So this T formula will tell me what any of them cost. So for example, if I replace n with 5, what should the answer be? 2.55. So if I replace n with 5, I'd have 1.8 plus 0.15 times 5. And that will come out as 2.55. This Tn formula gives me the cost of any floor I want. If I was to build 20 floors, I would just replace n with 20. It'll tell me how much the 20th floor costs. If I want the 72nd floor, which is going to be phenomenally expensive, I replace n with 72. Everybody right with that? Okay. So, using your formula or otherwise, find the construction cost of the top story. So the top story is when n equals 72. So, here we are here, and now we're just going to replace n with 72. So 1.8 plus 0.51 times 72. Anybody get that out?
12.6 million.
12.6 million, that sounds familiar. Okay, that's that one done there. Now, what's next? D. Find in terms of n a formula for D. What's the key word here? Total. What form am I going to use there? Sn. Now let me explain what Sn does. The Sn formula is basically adds them together. Sn. So guys, if I ask you what S1 is, can anyone tell me the answer for S1? S1 is 1.95. Can anyone tell me the answer for S2? 1.95 plus 2.1, which would be 4.05. You have a way of checking if your formula is right. Now we just got to construct the actual formula. A is 1.95 and D is 0.15. Now look at this. Your Sn formula for a linear sequence is that one there, yeah. It's in your log tables. Now we leave n the way it is. 2 times A, 3.9. 3.9 mil, okay? And then D is 0.15. 0.15 gets multiplied by the n, it comes 0.15 n. The 0.15 gets multiplied by the minus 1, it becomes minus 0.15. Then we get n over 2 into, anybody? 3.9 minus 0.15? 3.75 plus 0.15. Now guys, I'm going to show you a really easy, good way of getting marks here. I guarantee you the next thing they're going to ask me is something like, we have this much million to spend, how many floors can I afford? So, find the total construction cost. So he wants me to find out what 72 floors cost, yeah? Now, you're going to just replace n with 72, but I want to take you one step further, okay? So what I want to show you is this. Here's a real cheat for this. Do you know our table function? Remember we had a table that will tell us the cost of, actually I'll explain 2 things. The first way we can use our table function is like this. You could replace, instead of using Tn, what could you use? F of x. Instead of using n, use x. Now look what happens here. There's a real cheat regards information. Just go, start from 1 to 20. This tells you the cost of each floor. First floor is 1.95. It will tell you the cost of every floor. Okay? And that's really handy to have if you're looking for stuff. Now, if you want an extra cheat, is that you can actually reconfigure this formula, so it will tell you the cost of, the total cost of having so many floors. So I'll show you as an example. You just put it back in again, except this time you're going to do x over 2 on the outside, because you're not using n. And then on the inside, what do you have? 3.75. There's an n somewhere there, isn't there?
Yeah.
That's an n there. 0.15x. Now look what happens here, guys. 1 to 10, we'll go 1 to 20 starting off, okay? The cost of the first floor, 1.95. First 2 floors added together, 4.05 as predicted. And then how much does the first 20 floors cost? 67.5 million, okay? So we can figure out a lot of answers that way. If I want to figure out what 72 is, I'll just start at 70, end at 72. 72 is 523 million point 8. Now, just replace n with 72. 72 divided by 2, 3.75 plus 1.57 times 72. I already know the answer. It's 523.8. Done. A rival developer wants to build a taller skyscraper. He purchased a suitable site for 310 million and he has a total budget of 950 million. How much money does he have to spend on the actual building? 640 million. Okay? Now, this is a very difficult question. But to get high attempt marks, all we have to do is this. Let's ramp it up to about 90 stories, 100 stories even. So let's start at 70. Let's start at 70 and go up to about 90 and step up 1. Keep going down. When does his budget run out? 80 floors. So you know the answer is going to be 80 floors. Now, the textbook way of doing this is the last question on the test. This is basically an honour standard question. The way they want you to do it is like this. You go back to your formula before you put the 72 in it, and that's your formula. And they're saying is Sn represents the cost. So you put 640 there. Now I'm going to multiply this out. So I'm going to halve 3.75 and I'm going to keep it in fraction mode. Now the other way is easy for getting attempt marks. You might not be entitled to full marks. This way is 15 over 8n when I multiply the first one out and I multiply the second one out, 0.15 divided by 2. 3 over 40 m squared equals 640. Find the lowest common denominator for both sides. What is it? 40. Multiply the bottom by 5, the top by 5. Go over the other side, multiply the bottom by 40 and the top by 40. I get 60n, I get 3n squared, and I get 40 times 640, which is 25,600. I then bring it all over one side. I then, in turn, start a minus b formula. There's still stuff to be learned. Even if you're completely lost, you can still revise the minus b formula here. Okay? Now, please remember my answer, I'm predicting an answer of somewhere between 80 and 81, haven't I? Because that was the floor I needed to build. So, minus b, minus 60, plus or minus the square root of b squared, which is 60 squared, minus 4 times 1 times minus 25,600. Can anybody in the class tell me, do I need to take a negative answer into consideration? Can I take a negative answer into consideration? Why? You can't have negative stories. So, therefore, the negative sign can disappear. I'm only considering the positive sign. Okay, guys. Minus fraction button. Minus 60 plus root 60 squared minus 4 times 1 times minus 25600 all over 2. 132. Now, that obviously means I went wrong somewhere. Huh? Oh, it's 3, isn't it? 3. So let's see if that makes any difference. I think that'll make it bigger, if anything. No, it made it bigger. It's alright, guys. Stuff like this happens all the time. Just gotta stick with it. So, what's a half of 3.75 again? Just gonna double check. I'll pause it here. Guys, mistake was made. We know the answer's in between 80 to 81. Hence the power of the calculator telling us we've made a mistake in the minus b formula. The mistake was made in creating the minus b formula. My mistake was made right here, which is 5 multiplied by that's 75, which in turn makes that 75. And this is the great thing, you can just literally come in, all your previous work is not completely useless, just share everything to 75. Hopefully the calculator, sometimes the calculator stores stuff. There we are there. And look, quick way to victory. Just put that as 75. Minus 75. And the answer is we're 3 times bigger than we wanted to be. Where was there 3 earlier? The a value was 3. I'm so used to it being 1 that I forgot to put a in as 3. So a value was 3. So it's 2 times 3. Not a bogey question, but a bogey teacher. It's in between 80 to 81 as expected. Because you can't afford the 80 floor, you only have 80 floors. You can't round that up because you haven't got enough money. 80 floors.